Hello folks, here I would like to do a quick revision for chemistry about the mole concept, and I believe that the mole concept is so fundamental and important that everyone or every student has to be well versed in it. In fact, the mole concept stretches everywhere in chemistry to most, I would say, almost all of your other topics. So which is why I highly stress that any student of chemistry ought to have a very strong knowledge of this mole concept. The mole is actually an SI unit. This is the short form, MOL, which stands for the full word MOLE. Now, whenever you talk about the mole, do be mindful of what compound or what element you're looking at. So for example, if you're talking about helium, now again, you should hopefully you should know that helium exists as atoms, and therefore it will have an atomic weight or relative atomic mass of 4. Right. Now, sometimes we abbreviate this relative atomic mass as AR, though occasionally I also use the full abbreviation, relative atomic mass. Now, on the other hand, if you're looking at a compound, let's say CO2, you ought to be familiar by now that CO2 exists as molecules. And of course, also to go a bit further, it is predominantly a covalent compound. Now, as a result, instead of using AR, we represent the relative molecular mass as MR. Or sometimes you write the full initials as RMM. And of course, hopefully by now you can calculate the MR for CO2. If you look out your periodic table, you have 12 for carbon and 16 for each oxygen. So that would give you an MR of 44 for CO2. Now, on the other hand, if you're looking at a compound like, let's say, sodium chloride, again, be aware that this is an ionic compound. So we don't really count NaCl as a molecule. So instead, we use the term formula unit. And of course, in this case, technically we don't use relative atomic mass since it's not in the form of atoms. Neither do we use relative molecular mass since NaCl is not in the form of molecules either. So in this case, it's a relative formula mass. And the short form is similar to RMM, is still MR. Well, again, similarly, I simply add the relative atomic masses of sodium and chlorine together. Sodium will be 23, chlorine will be 35.5, and that gives you a MR of 58.5. Now, for the purpose of O levels, your relative atomic mass, in this case 4 for helium, relative molecular mass 44 for CO2, relative formula mass for NaCl, they do not come with units. However, to be also mindful that we also use another term known as molar mass. And this basically tells you the mass of a substance for 1 mole. So in the case of helium, 1 mole of helium will have a mass of 4 grams. Now again, take note of the units. We are using grams for the mass here. For those who are familiar with your science, you realize that gram is not an SI unit. Nevertheless, molar mass, at least for O level, is typically based on grams. Now, similarly for CO2, 1 mole of CO2 will be 44 grams, and 1 mole of NaCl will be 58.5 grams. Now here I will add in your first formula. So based on the previous contents, we can come up with this formula. Number of moles of a substance is equal to mass in grams over molar mass of that substance in grams. And obviously, guys, be willing to manipulate this formula. Alright, so I can always rearrange it, and I will get a mass in grams equals to number of mole of that substance times its molar mass. Now you may be wondering, why are we so interested to use moles in chemistry? Well, it offers certain conveniences whenever we talk about chemical reactions. Now, for example, if let's say I have carbon, let's say it burns in oxygen, that would give you CO2. Now, there are two ways to look at this reaction. One way is at the molecular level. So, basically, at the molecular level, one atom of carbon reacts with one molecule of oxygen to give you one molecule of CO2. Now, alternatively, I can also look at it from the molar level. Right. Similarly, 1 mole of carbon reacts with 1 mole of oxygen to give me 1 mole of CO2. And based on the molar level, I can actually calculate the masses of substances necessary to complete this reaction and the mass of products formed. So in this particular case, one mole of carbon is 12 grams. 1 mole of oxygen gas O2 will be 32 grams. And therefore 1 mole of CO2 will be 44 grams. Now, if we are using purely masses, we can't actually come up with these numbers. Alright, these numbers only make sense when we talk about the reaction in terms of moles. Now let's go on to another topic, concentration. Now for O levels, there are two important concentration units that you ought to be aware of. Now the first one is concentration in terms of mole per dm cube. Guys, I hope you realize you can actually get a hint of how the formula looks like based on the units. Mole per dm cube. That means mole of solute as the numerator over volume of solution in the denominator. But just be careful, make sure your volume is in dm cube. And a side note, all of you are expected to know that 1 dm cube is the same as 1 liter, and it is equivalent to 1000 milliliters or 1000 cubic centimeters. So, right, that would be the first formula that you ought to know whenever you talk about solution. Well, let me just emphasize that this is referring to concentration of solute in a solution. And for O-level purposes, your solution is typically an aqueous one. Now, the other important concentration unit is in terms of grams per dm cube. Now, again, similarly, the units should give you a hint of how the formula looks like. Grams per dm cube. So the formula looks like this. Mass of solute in grams over volume of solution. Similarly, this is in dm cube. And just be mindful, we are interested in the solution volume as a whole, not just the solvent itself. So just keep that in mind. Now, one last thing from the previous slide, we actually had this formula. Mass equals to number of moles multiplied by molar mass. Now, imagine if I divide both sides by volume of solution. What do you see now? You notice that I can derive a third formula, concentration in grams per dm cube equals to concentration in moles per dm cube multiplied by molar mass of your solute. Now, this last formula here, well, depends. It may or may not be useful for you. It definitely is a shortcut for me to make certain calculations or conversions between concentration in grams per dm cube and concentration in moles per dm cube. Now, here I touch on another important subtopic about gases. And guys, hopefully you remember this golden rule. At RTP, which stands for room temperature and pressure, 1 mole of any gas, and we do mean any gas, CO2, typically in gaseous form, but of course sometimes it's necessary for you to check the conditions whether that substance is existing as a gas. H2O in vapor form or steam form, helium gas of course. So 1 mole of any gas at room temperature and pressure occupies 24 dm cube. So if you decide to use your proportioning method, 0.5 mole of any gas, and of course this only applies at room temperature and pressure, will be half of 24, or 0.5 times 24, that will give you 12 dm cube. Or, well, if let's say you have 2 mole of gas, well, you do the same method, 2 times 24, that will give you 48 dm cubed. And before I forget, keep in mind, it's useful to know, just in case, room temperature refers to 25 degrees Celsius. Well, I mean, in this case, room temperature is conventionally agreed upon value at 25 degrees Celsius. It does not refer to your actual room. Let's say in Singapore, whether air conditioned or not, it does not refer to that kind of temperature. It is conventionally fixed at 25 degrees Celsius. And well, pressure is basically atmospheric pressure, but they also fix it at a certain value, in this case 1 atmosphere. Right, so the other common mistake which I tend to see is, if let's say you want to find out a certain volume of gas, let's say I give you, well, perhaps 4 dm cubed. How many mole is this? Now, this is when some students will get confused. They will come up with perhaps a funny kind of mathematical operation. For example, they'll take 24 divided by 4, which gives you 6 mole. Now, this is of course wrong. Well, a very easy way to look at it is, if 1 mole of gas is already 24 dm cubed, and over here we are talking only about 4 dm cubed, so you would expect your answer to be less than 1 mole. So instead, my suggestion is this, especially for those students who are very fond of using the primary school method of calculation, especially using units in their primary school, and they carried it into their secondary school days. If you want to use that method, which is actually a form of proportioning, I would advise that rewrite this statement. Alright, instead of writing 1 mole of gas occupies 24 dm cubed, I reverse it. 24 dm cubed of any gas makes up 1 mole. So therefore, if you are using your primary school method of units especially, you tend to go into calculating 1 dm cubed or 1 unit. So that would give you 1 over 24 mole. And when you're asked to calculate how many moles take out 4 dm cubed, instinctively you will remember 1 unit multiplied by the number of units here, which is 4, and you get 1 over 6 mole, which is the answer in this case. Now, continuing from the mole concept regarding gases, I have seen that there are 2 major types of questions you are likely to face. Now, the first type is, you are given a certain mass of a gas. Now, again, a reminder, do check that it is indeed a gas, and do check that it is measured at room temperature and pressure. And from this mass, you are supposed to calculate the volume of the gas. Now, again, make sure your units are correct. Mass should be in grams. So the next thing you'll be doing is convert your mass to number of moles of that particular gas. Now, that also means that you need to know what that gas is. You need to calculate the molar mass of the gas. So again, using my earlier formula, number of moles equals to mass over molar mass. So once you have number of moles, you simply use your proportioning method to find out what is the volume of that gas. And again, units are in dm cubed. Now, the other way that a question could be asked is you're given the volume and you are asked to find out what is the mass of that gas. Now, this is simply a reverse of the above method. So again, check your units are in dm cube. And since 24 dm cube makes up 1 mole, find out the number of moles of the gas by dividing by 24. And once you have the number of moles of the gas, find out the mass using the earlier formula, number of moles times molar mass. Now, I'm very particular about units because using the wrong units will give you the wrong answer. So again, double check, make sure molar mass is in grams, and that will naturally give you your mass in grams as well. And of course, the last way to look at this, what I've shown earlier, right? Essentially, if I have 24 dm cube of any gas at room temperature and pressure, this is equivalent to 1 mole of the gas, and this is also equivalent to the molar mass of that gas in grams. Right, so keep this relationship in mind. Now guys, I hope that you had a beneficial session through this video clip. I will in fact, I intend to put up more video clips in the future, so do keep a lookout. But in the meanwhile, if you want to find out more about iMatter Learning Center and what we do, our enrichment programs, our tuition programs, do check out our website over here. Right, thank you and goodbye.